Another really neat theorem that links together various ratios of lengths is known as the secant-secant product theorem. So now imagine we have two secants that intersect outside the circle here at E. Now the question is there some relationship between the four line segments that we see? Namely, this line segment, this line segment, this line segment, and this line segment. And the answer is yes. In fact, it's very similar to the chord-chord product theorem. We see that AE, so AE multiplied by BE, so multiplied by this, is going to be the same number as the length CE multiplied by the length DE. So visually what we're saying is this length multiplied by that length will always equal this length multiplied by that length. Let's see the secant-secant product theorem in action. So suppose we're given this situation. So in this case, we have a circle. We have these two secants meeting up at C. We're told this is 7. We're told this is 5. We know this is x. We know this is 6. And our question is to first figure out what x has to be and then figure out the length of each secant. Now, one of those questions is really easy. This secant we can figure out pretty fast. It's just 7 plus 5, and that's 12. So AC equals 12. That was pretty easy. All right, but now the extra main. So let's now set this up. What do we know? We know that the total length multiplied by this length is going to equal the total length multiplied by this length. So what do we see? What we see here is total length is 12 multiplied by the little length here is 5. And that's supposed to equal the total length here. Now, what's the total length here? It's actually going to be x plus 6. And I take that entire quantity and multiply it by 6. Notice, by the way, that I have these parentheses here. Do you see these? This is an important thing from algebra that we saw. The 6 has to multiply the entire number. So I've got to make sure that I'm going to distribute that 6 across. And so those parentheses have to be there. If they weren't there, like that, then we just would have the 6 times the 6, and we'd never get that 6 all the way over to the x. So those parentheses are actually really important. All right, anyway, we've produced now an algebraic equation that we can solve. We have 60 equals, and if I distribute that 6, I see 6x plus 36. If I bring the 36 over by subtracting 36 from both sides, I see 24 equals 6x. If I divide both sides by 6, I see that 4 equals x, and so I see the answer x equals 4. So this little piece right here is 4. That's the answer to the first question. And the second question is, what's the entire length? Well, the entire length, therefore, of CE would equal, of course, 10. 6 plus 4. And so you can see that this wonderful secant-secant product theorem allows us to, again, discover new insights into the circle.